All right, so today we're talking about the area of parallelograms and triangles. Before we get started, I just want to kind of go over briefly what length and area are, and then next chapter we'll get into what volume is. So area can be thought of as a one-dimensional, how many steps do I need to take? Or in this example I wrote, how many 1 foot lengths of cord do I need to piece together to get from here to there, right? And it could be a curved path. It could be wrapped through 3 dimensions, right? Over this desk, under this. But the length itself is this one-dimensional string or rope. That is, I can measure how far I jogged just by laying that rope along my path and say, okay, I jogged this many feet or this many miles. Now, an area, though, is saying how many 1 foot by 1 foot like square pieces. Maybe you could think of it like papers or like quilt patches or something, but it's a 2-dimensional sheet. And you're saying how many of these patches do I need to lay out end to end so that they cover a 2-dimensional surface. So rather than how long is this in feet, meters, kilometers, whatever, instead what you're saying is how many of these patches do I need to cover a region. So in this rectangle here, I counted there are 24. If each of these are 1 by 1, I counted I can put 24 of these down to cover this region. Now a shortcut for that, rather than counting all those out, like if you have that many cookies on a cookie sheet, I'm not actually going to count. I'm going to say, okay, well I've got 3 rows, right? I've got 3 rows here. I've got 1, 2, 3 rows. Each row has 8 columns in it, and they all have the same number, so I could just do 3 times 8. So for a rectangle, which also means for squares, since every square is a rectangle, but at least for rectangles where we have these right angles, we could just fit these in and say 3 times 8 is 24. And this works for fractional squares. If I had off the end like a half a square, I could add up a half a square and a half a square and a half a square and get 1.5 squares. So I could still do 3 times 8.5. This works with decimals with fractions. Okay, so that's the whole idea of what area is. Okay, so now let's specifically look at parallelograms then triangles. Okay, so if we take a parallelogram here, the big idea, the way we're going to look about this, is we're going to cut it up and rearrange it. And the main thing we're going to do is by drawing this height here, and an important note is that height is always perpendicular to the base. And it doesn't matter which base you could choose. You could rotate this thing sideways and talk about the height from this base right here is perpendicular to this, right? You could have found that base and height, but we arbitrarily chose the one on the bottom. Okay, so now that we have that, we could cut off this entire triangle and we can move it over to here. Now, how do we know those fit? Well, if only we could show that these 2 triangles are congruent, we know it would fit. Well, we know, since this is a parallelogram, that the opposite sides are congruent. Okay, we also know there's a right angle here and a right angle here. Now we have a couple ways we could go from here. The easiest is maybe knowing that consecutive angles, these bottom 2 angles in a parallelogram, are supplementary, and then saying, well, this straight line, this angle over here would be supplementary, and so 2 angles supplementary to the same are the same. So this angle could be shown to be this angle, so the bottom left angle, those triangles, and by AAS they're congruent. You could also think, since the top and bottom lines here are parallel, then what you know is whatever distance apart they are on the left is the same as if I were to, whoa, I've taken the whole thing there, is the same as if I were to just take this height and slide it over, and I didn't grab the whole thing, but that would be the same height all along, just like railroad tracks. They're the same distance apart no matter where you measure, right? That's the whole idea of parallel. They're going in the same direction, so they stay the same distance apart, never getting closer or more further apart. So you could say that the height is the same too. But either way, we've got more than enough information now to show those 2 triangles are congruent. So after we rearrange it, what we get is we get 4 right angles, because now this height is an edge. This other height is an edge. We have this slanted side, let's call it A, which wasn't so important, and now it's just on the inside of the shape. But what we have is we have this top base that never got changed. So whatever this was is still the base of this rectangle. And then we have this height that was the same on the left and right, and that height is still the same over here. So we rearranged this generic parallelogram that could have been any parallelogram, and we made a rectangle with the same base and height. So if we could rearrange the parallelogram into a rectangle with the same height, the area of the rectangle is base times height, so that must mean the area of a parallelogram is also base times height. And so if we know that's true about every parallelogram, then that's true about rhombuses, squares, and rectangles, since all of those are parallelograms. So every parallelogram, the area is base times height. Okay, so a really straightforward application of that is here on number 3. We've got that the area is base times height. The base here, and again, I could use any side for the base. The reason I'm choosing 7 as the base is because we know that 4 is perpendicular to this side, so that fits our base and height must be perpendicular. So then we get, yeah, it's just 7 times 4, or the area is 28. Okay, and we're not so worried about units here. You could say units squared if you want. Okay, now over here, I'll tell you by far the most common mistake is, and I'll write not area equals 7 times 8. Right? It is base times height, but that side 8 is not a height because, and I wrote it up here, the height and the base must be perpendicular. Must be perpendicular. The numbers you are multiplying must have a right angle between them. Okay? So down here, let's look at what we've got. Well, if we know this is a parallelogram, well, we know opposite sides are congruent. So we know this whole top side is 7, which means this missing part here is 3. Well, and opposite sides are congruent, so that 8 over there is an 8 over here. And so here's a really common thing that comes up. Since we know we've got the height must be perpendicular to the base, well, anytime we have a right angle, we know we could use Pythagorean Theorem, right? That comes up anytime we have a right angle. And also, we could use trig, right? Those are two things that come up often when we see a right angle. So in this case, if we're looking for the height, because it is definitely not 8, 8 is not the height if we're using 7 as the base, then we could use Pythagorean Theorem to find that. So off to the side, I'll say, okay, what is this height? The height is h right angle 3 and 8. So h squared plus 3 squared is 8 squared. So h squared plus 9, that's 64. So h squared is 55, so h is square root of 55. Okay, so now when we want to find the area of this, it is base times height, but now since the base and height must be perpendicular, we've got the base of 7 times its corresponding height, which is root 55. And 7 times root 55 is fine, or you could use a calculator to approximate that. Now again, I could have used 8 as the base, not to confuse you, but if I had chosen 8 as the base, I would have needed this height here, perpendicular to 8. And we could calculate that. I mean, if the area of this shape is 7 times root 55, and the base is 8, then this height we could easily calculate by saying, okay, 7 root 55, the area, is equal to base times height, 8 times its height. And so we could find that. The height of this would be 7 root 55 divided by 8. So we can find that other height. You could use any side of this shape as the base as long as you use its corresponding height. Okay, so that was a parallelogram. Every parallelogram, the area is base times height. Okay, what about a triangle? Well, again, we're going to think about it in terms of can we rearrange this or something. Now, in this case, rather than rearranging the original shape by cutting it up, we're going to rotate this shape 180 degrees around the midpoint of a side. Now what this does is, think about it. Whatever was right here, this half of the side gets rotated and is now up here, right? 180 degrees in the other direction. Whoops. 180 degrees in the other direction makes a straight line. And we know that they were congruent because they were the same length. So both of these land on top of one another. Okay, so this side is right where it was originally, still the same length, congruent to itself. But look at what we get now, and this is cool. We get that this angle that was down here gets rotated, or sorry, we're in blue. So this angle that was right here gets rotated and spun around 180 degrees down to here. And those are congruent because it's the same angle. And yet they're alternate interior angles in this larger four-sided figure. So we know that this side must be parallel to this side. Now we also see that this angle that was right here in the bottom right got spun 180 degrees and is now in the top left of the new triangle. But those are also alternate interior angles telling us that the top side and the bottom side of this four-sided figure are parallel. And so we get a four-sided figure with opposite sides parallel. This is just a parallelogram, and we know the area is base times height of a parallelogram. But if two congruent, identical triangles add up to be the area base times height, we just divide it by 2 to find the original area. So that's a cool way to look at maybe a formula you've seen a lot in the past and then never wondered why it's true. Now, one thing to specify is you'd be like, well, maybe the parallelogram has a different base and height than the triangle. But let's look at it, right? So here's the base of the parallelogram. That's the same base as that's the base of the triangle. It's the same base as the parallelogram. And look at, here's the height of the triangle, and that is the very height of the parallelogram. So it is the same base and the same height. So yeah, base times height divided by 2. Okay, so I wrote that explanation out. But again, area of a triangle, 1/2 base times height, something you've probably seen many, many times. And the one thing to always remember is that that base and that height you're talking about have to be perpendicular. So for example, a really straightforward example here is number 6. Now notice I'm not talking about the base being on the bottom arbitrarily. I can choose any side of the triangle to be the base as long as then the height is perpendicular to it, right? So the height from here down, the altitude drawn to that side is 13, so that's my height. So area equals 1/2 base times height. So we've got 1/2 10 times 13, or 5, 1/2 times 10 times 13 is 65. Okay. Now again, I get to this one like number, is my made up example. We get to another one where we're missing the information we need. If we want to solve this, we go, okay, well I know, and I'll do this in a different color. Say, okay, I know it's 1/2 base times height. Okay, so the area is 1/2, but now what's my base? I could choose any side of this triangle to be my base, but immediately I see this right angle. So I think I'm going to use these two sides as my base and my height. Since they're both sides of the triangle, it doesn't matter which one's which. So I'm going to say, okay, 1/2, my base is 18, and now I need to know my height. So here's my h. Well, how could I find it? Again, when you have that right angle, you could think I could either use Pythagorean Theorem or trig. So off to the side here, I'll go, okay, let's divide this triangle by 6. Just, scale factor it down and say this is similar to 5, 3, and w. So either using Pythagorean Theorem or just noticing that this is a 3, 4, 5 triangle. So w has to be 4. Then we go back, so we multiply by 6, and we get that h is 24. Okay, so now getting h is 24. The area of this triangle is 1/2 18 times 24, or 9. That's 1/2 of 18 times 24. So the area is 216. And again, you can put square units if you want. Okay, but get used to missing a side and being able to find that missing side's value. All right, so those are going to be pretty straightforward. Again, area of a parallelogram, base times height. Area of a triangle, 1/2 base times height. But now I'll throw some curveballs at you, right? I'll say, okay, well, I'll give you the answer. The area of this triangle is 36. Okay, now figure out what the height or the base was. So we go, okay, well, I know the area is 1/2 base times height, and I know what came out as 36. I know I plugged in a base of 12. What is that corresponding height? And notice it's labeled with algebra. It's saying let's work backwards, step by step, and kind of unravel this with algebra and figure out what got plugged in. So I'm going to simplify this to 36 equals 1/2 of 12 is 6. Oh, I'm using h and there's an x. It's okay either way. So let's divide by 6, and we get that the height is 6, or that x equals 6. Okay, similar over here, we go, okay, well, I know that the area of a parallelogram is base times height. I know that what comes out here is 276. And what got plugged in, let's see. Well, the base from one side to the other is x times the height. Now, we had to extend this base out to the side and say perpendicular to that base is this height of 12, so times 12. And then you just go ahead and say, okay, well, I could solve that. Just divide both sides by 12. Whoops. And we get x equals 23. Okay, so be able to go backwards with algebra and solve that. But really what we're building up to, and this is what most of the quiz questions will probably look like, are some composite figures. Now, composite means it's composed of multiple things. It's made of more than one thing. Yeah, I could go into more what that means. But basically, these composite shapes just means it's two separate shapes, like a parallelogram and a triangle, glued together, or just attached. And so the way we're going to find the area is for this first one, I'm going to find the area of the top triangle, and I'm going to add it to the area of the rectangle, right? And also I'll find two separate areas. Let's look for this one first. And then after that, I will separately look for this area on top, and then I'll add the two areas together. Okay, so on top, we've got a height of 5, so 1/2 base times height, plus area of a rectangle. That's a type of parallelogram, so that's base times height. So I've got 1/2. The base, since this is a rectangle, opposite sides are congruent. So there's a 17 up on top. So the base of that triangle is 17. The height of the triangle, I saw that right angle there. So the height is 5. Plus the base of the rectangle is 17. The height is 8. So I get, oh dang, this isn't going to work out nicely. But okay, 1/2 of, that's 50, that's 85. Plus, and then this turns out to be 80 and 56, so 136. So this is 42.5 plus 136 is 178.5. If I made a mistake, I apologize. So that's our total area there. Again, the idea is chopping it up into manageable figures, okay? So over here on the right, I would chop this out. Say, oh, look at this parallel line and parallel line, giving me that I get the area of a triangle plus the area of a parallelogram plus the area of another triangle adds up to the total area. So the first triangle, I mean, I know the formula for each one just to write it out. 1/2 base times height plus base times height plus 1/2 base times height. Okay, so our first one is 1/2. The base is 9 times, what's the height? Well, look at in here, we have the two parallel lines are 13 apart. So it doesn't matter where I move that, right? If I move it left or right, that 13 is the distance between the two parallel lines, and that never changes. Parallel lines never get closer together or further apart. So that height of 13 stays the same for all three shapes. And so I get, this is times 13 plus base of 18, height of 13, plus 1/2, the base of the last triangle is 11, times, again, a height of 13 for all these shapes. And then it just becomes arithmetic. For me, it's easiest if I factor out the 13 from each of those. So I get 1/2 of 9 is 4.5. Plus, I factored out the 13, so I'm left with 18. Plus, 1/2 of 11 is 5.5. And I factored the 13 out of each one because they all had a 13. So what I get is 13 times 4.5 plus 5.5 is 10. 13 times 28, that is 364, I think. Area is 364 of that total shape. Okay, so that is very similar to what you'll do on your homework. I'll do a couple more practice problems on IXL, but that's really it. So stick with me if you want more problems. If not, enjoy. Okay, so these problems are going to be pretty straightforward. just going to kind of walk through some. So again, triangle, that's area equals 1/2 base times height. It doesn't matter which one you choose as the base, so long as your base is a side of the triangle, complete side, and your height is perpendicular to it and going to the top. So we could do these interchangeably, but we get 1/2 4 times 6. So 1/2 of 4 is 2 times 6 is 12. So all right, the next one. Okay, we got a parallelogram. Again, the base has to be an entire side length. So we get area equals base times height, where the base is 7 times. And then we get the height has to be perpendicular to the base and go to the top of the shape. So we got 7 times 5. So area of 35. Another parallelogram, again, base is any side length that goes from one side to the other. So area equals, oops, let's get out of this. Area equals base times height. That base is 5. Perpendicular to that, the height is 6. So 30. Okay, triangle is 1/2 base times height. Again, that base we're choosing in this case is 17 times a height of 16. So 1/2 of 16 is 8 times 17. That's 80 plus 56, so 136. And that's really it. I just want to show you some quick practice. So these problems get pretty redundant. They just become decimals. Here's another one. Actually, this is a good one to mention. The height absolutely can be outside of a triangle if the triangle overhangs, right? And the tip isn't over the base. Now, of course, I could flip this triangle over so it looks like this, and I could think of this base on bottom and the height being to that base. So I could always use any side as the base. It just happens that I'm given this side is 13 and that top side is 14. So obviously I'll choose that side, but 1/2 base times height. This height is perpendicular to the base. It goes from the top down to distance from this base, even though the base had to be extended. So we get 1/2 of 13 times 14. So 1/2 of 14 is 7 times 13, which is 70 plus 21, so 91. And that's going to be it. So I hope you enjoyed it. Oh, and it can't read my writing. Okay, well, good luck on your own. 91 on that.